Okay, let us take a matrix A, and we'll use our notation A11, A12, A21, A22. Okay. 2 by 2 matrix. We define the determinant of A. Another symbol for the determinant is a straight line up and down. We will be using that symbol. We'll be using both interchangeably. A12, A21, A22. So it depends on what it is that you're talking about. You use the lines when we want to specify the entries. We use this more functional notation, determinant of this matrix A, when we want to simply speak about it in the abstract. So we define it as A11 times A12 minus A12 times A21. The pattern is this times that minus this times that. Again, A11 along the main diagonal, this times that minus that times this, including the signs. Let's do the same for a 3 by 3, and then we'll do some examples. So let's say that B is our 3 by 3, so we have B11, B12, B13, B21, B22, B23, B31, B32, B33. Linear algebra is notationally intensive. Okay, now the determinant of B is equal to, okay, I'm going to write it out, and then we'll talk about an actual pattern that you can use. B11 times B22 times B23 plus B12 times B23 times B31 plus B13 times B21 times B32 minus B11 times B23 times B32 minus B12 times B21 times B33 minus B13 B22 B31. Here is the pattern. There are different ways to think about this, and I know that many of you have, of course, seen determinants before, back in high school and perhaps in other areas of mathematics, perhaps in some college courses in calculus or something like that. Here is the general pattern. Notice we have some that are plus, 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 and some that are minus, minus, minus. First one is B11, B22, B33. Going from top left to bottom right, multiply everything down this way. The second entry, just move over and go down again to the right. B12 times B23, but since you have nothing over here, just go down to this one because you need 3 entries. Notice each one of these has 3, 3, 3, 3, 3, 3. You need 3 factors in the multiplication. So it's this times this times this. Now you go to the next one. B13, there's nothing here, but you need 3 of them. So you go here and here. So it's B13, B21 times B32. That takes care of the plus part. Now let's deal with the minus part. Go back to the B11. Well, B11, now try going down to the left. Well, there's nothing here at the left, but you need 3 terms. So it's B11, B23, B32. Go to the next one over. B12, B21, there's nothing here, but there's one here, B33. B13, B22, B31. There are different kind of patterns that you can come up with. This is simply the best pattern that I personally have come up with to work with 3x3s. Again, you've probably seen determinants before, so whatever pattern you come up with is fine. I think this works out the best simply because you're going to the right, positive, you're going down to the left, negative, if that makes sense. So those have positive signs. When you're moving in this direction, you have negative signs. And of course, in this, you have a 3x3. Each term has to have three things multiplied by each other. Okay, let's do some examples. Let's go back to, actually, you know what? I think I'm going to try blue ink. Let's define A as 1, 2, 3, 2, 1, 3, 3, 1, 2. Okay, so let's do our pattern. Let's see, let's go ahead and put something like that. And we'll say the determinant of A. Okay, 1 times 1 times 2. It's 2. Okay, plus 2 times 3 times 3. 2 times 3 is 6. 6 times 3 is 18. Plus 3 times 2 times 1, 6. Okay, now minus 1 times 3 times 1, it's 3. Minus 2 times 2 times 2. 2 times 2 is 4, times 4 is 8. Close this 8 off. Minus 3 times 1 times 3, minus 9. When we add them all up, hopefully my arithmetic is correct. Please check me. You should get 6. So again, positive this way, negative that way. Okay. Let's do a 2 by 2. Let's say B is equal to 4, negative 7, 2, negative 3. So now we have some negative entries. Okay. The determinant of B is equal to this times this. 4 times negative 3 is negative 12, minus this times this. This times this is negative 14. The minus sign has to stay. So it's negative 12 minus a negative 14, minus 12 plus 14, it is equal to 2. Okay? So these signs here, this plus here, plus here, plus here, negative, 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 they always stay there. It doesn't matter what these numbers are. If this is negative, then a negative times a negative is positive. But you have to have 3 positive terms in a 3 by 3. You have to have 3 negative terms in a 3 by 3. Negative in this case. It just depends on what these numbers are. But those negative signs and these positive signs have to be there. They're not part of the arithmetic. They're part of the definition of the determinant. Okay.